theory of relativity that mass and energy are but different manifestations of the same thing, a somewhat unfamiliar conception for the average mind. Furthermore, the equation E is equal mc squared, in which energy is thought equal to mass multiplied with the square of the velocity of light, showed that very small amount of mass may be converted into a very large amount of energy, and vice versa. The mass and energy were in fact equivalent, according to the formula mentioned above. This was demonstrated by Cockcroft and Walton in 1932 experiment.
University lives New Jersey's most famous foreign-born citizen, Professor Albert Einstein, who helped discover the atom bomb.
Hello. Yeah, my name is Rod Kowicki. I'm doing this video. I'm an author. About 13 ebooks, paperbacks on Amazon, on a new theory about the universe. It correlates with the latest physics writers. Fluently Einstein, fast in light, speed space travel. According to Einstein, you need a new theoretical force to bend space and to travel faster than light. But in 1925, Edwin Hubble came in with a new theory. He investigated and found out the universe was expanding. And not only at a velocity greater than the speed of light, but a push force beyond the speed of light. Now he calculated the galaxies were expanding away from each other in uniform motion. That means all happened, all of them the same way, at 43 miles per second. Einstein's theory correlates that the universe is limited to the speed of light. In other words, everything's inside this bubble that you can't go faster than the speed of light. I bid the difference. My books bid the difference. You look at Edwin Hubble's theory of expansion at 43 miles a second and think of a force. Now that's the miles per second that they are being pushed at a constant rate. The force involved in making this happen have correlated to approximately twice the speed of light. Not only twice the speed of light, but a force that is a force that is greater than light. Put it in perspective, I use 450,000 miles a second. That's how much force the space is separating the galaxy with. Not the velocity, not the speed. The speed is 43 miles a second. It seems like a slow car. But according to Einstein's views, if the universe is limited to a speed limit, which is the speed of light, you can't go faster. But in Edwin Hubble's theory, we are outside the universe. We are in empty space. And this empty space, this vacuum, has some kind of internal force which is much greater. I'm not talking about the velocity again. It's like a slow car. But whatever the allowance is perimetered to allow something to travel in space is weighed by the force, Einstein's speed of light. The Hubble expanse theory, or Kawicki expanse, is 450,000 miles a second. That's 100 degrees more than the 43 miles a second. Now we look at Einstein's car, local speed limits, a car on Earth, 10% of 100, or 9.8 meters a second, which is 1 mile a second, I think. I'm not sure. The car's running at 50 miles an hour. It's slowed down by a reverse push force. We call it gravity on Earth, but the propulsion values are 100%, which is, according to Einstein, the speed of light. And we look at the same dimensions, and we're looking in space and expanse. We find that the car is only running at 43 miles a second, but the force available is 450,000 miles a second. That means that the car has the ability to go twice the speed of light, which is 186 times 2, 372 plus or minus. Those are the external values, just lower values of a jet stream, let's say, between the galaxies, for a ship to travel. The jet stream, or whatever you want, space river, the river momentum is in the through the vacuum, is an open source. It's where that ability to travel faster than the speed of light acts as a standard theory. If you look at these dimensions and this theoretical new idea, you'll find them to be accurate. So we have a Einstein universe inside a bubble, and we have a Hubble universe and a Kawicki space expansion, which allows faster than speed of light travel based on the same principles in both of them. So theoretically, what I tell you is accurate. The idea of time travel, I think Einstein wanted to make himself a theoretical, what do they call it, fairy tale physicist, because his first book was What Would It Be Like? See, that's where people get tripped up. Einstein's theory, what would it be like, special theory, relativity, what would it be like to travel at the speed of light? So he talks about how he thinks it would be. And then he talks about this time, that if we are limited, but somehow we'd have to bend space. Who can bend space? Vacuum. Who can bend a vacuum? I mean, if you could see it. And made a fairy tale theory. Then later involved his findings of E equals mc square, which theoretically changes from E equals mc squared to 1/2 E equals mc square, and then in Hubble would be 2E times mc square. And that's using a value of two values. The one is matter, which E equals mc squared holds everything together. And the other one is equals mc squared to his velocity in time travel theory, which doesn't hold things together. Theoretically, I don't think time travel is possible. If the universe was traveling faster, I think he even said it, if it was traveling, if it had a force, vacuum force greater than the speed of light, then we could travel faster than the speed of light. But it doesn't mean that we could detach, in a small microscopic ship, change everything, let's say even one planet like Earth, and travel back and forth through time. I mean, theoretically, he thought it possible in 1905, but even in Hubble expanse theory, everything is pushed in uniform motion. That means that ship doesn't have the Earth by itself, and changing it would have to change the whole universe. It would have to make the whole universe turn backwards. The arrow of time turn backwards or forward or whatever at the speed of light. And this is why I don't understand it. So, this is the quantum physics theory. This is what I've correlated over 20 years that I've written books and did my study, and that's what I come up with, and I think it would be interesting to read. See, it takes a lot to understand what relativity is, because even though it was a 110-page book, I think, that Einstein wrote in 1915, nobody could understand it, what he was talking about. I mean, how can you calculate the speed of light? You got alpha, beta waves forward, and with alpha and beta waves backwards, omega waves backwards, and say that you can go backwards and forwards in time. One's going backwards, one's going forward, stimulating a speed or a tension for the velocity or the energy. See, E equal mc squared is towards energy. It's how you calculate mass energy, not velocity. It might be velocity but velocity doesn't change in the speed of light. And when you correlate and write a theory about one being matter, a spacecraft and planets and ships, and talk about light in comparison, you're going to get mixed up, because light has very little to do with matter. Only that mc squared is how much energy is in a certain weight of matter. A planet, star, a ship, a bowling ball, whatever it can be. And this is the quantum physics theory. I don't know why nobody has clicked onto this. I've done enough videos to make it easy to understand. I know this is not 1915 or 2020, and everything is correlated through paperwork, but we have the internet, we have the videos, we have all these things that I think this is kind of like important. You know what I'm saying? When computers came out in the early 80s, I think I got one in 1984, somewhere around there, and I sat down with this computer and said, what am I going to do with this? But I had played with paperwork and what do they call it, before computers. I forgot the name of them. They were little machines that you, like the typewriters, but they were advanced typewriters. I forgot what they are. So I knew what a computer was, but I didn't know what are you going to do with a computer. So I got in there and I found out about Word, and I started writing about relativity. Well, not relativity, but the speed of light, and what I actually thought. I've been thinking about this since I was young. You know, I knew about the vacuum. I think all kids, you know, that's one thing in school they teach kids at a young age about science, you know, about birds, about scientific view of everything that exists. That's science. And then they go into space, and they go into biology and all these things. And I got hung up at a young age. Go into a junior high school and you'll see these books on physics. These kids are supposed to learn, you know. And they're way ahead of us now because computers, everybody has a computer in school. I think they give it a computer and not no paper no more, which I think is bad. Because in economics, I saw what you get in the email, it can come from anywhere. But when you get in a letter, it comes directly to you from somebody. Oh, it could be forged the same way, but I have never heard of anybody doing that, you know. That's my idea. Well, I didn't get the bill, you know, or whatever. That's my the quantum physics theory. Check it out. And there's a lot of books. I'm on Amazon. I'm coming out with another one that basically spells it out. But again, like even Einstein, it wasn't until his later papers, 2 pages on this, 5 pages on this, that were published, that his ideas became public. You know, you have a book that he wrote, but you got to break it down so the public can understand it. And that's what I've done. So there's some books out there and new ideas, and I believe a standard faster than light speed space travel theory. I would call it standard based on the evidence. And you got, for your own reference, you have Einstein bubble that turns in 1925 to the Hubble sphere or balloon that is expanding the world. What exactly is expanding the world? What? A reverse black hole, possibly. Something of that matter. Something that is getting bigger, like the Hubble balloon. And everything is outside of this balloon and is being pushed in uniform motion at a force, not a velocity. Velocity is only how much the force is